All right, hello. I'm just going to go through all the problems of the test like I'm taking it, and this is for you to review your test and see what you did wrong and maybe find other ways to solve the problems, hopefully easier. So next time you would get problems like this, you would ace it, okay? So that first problem, we have 5, and we have to, it's times 5, times 5, times 5, times 5, times 5. I'm not even sure if I said it enough times. And we're supposed to just write that as a power. So what do? Well, the way exponents work is whichever number you're multiplying by itself, that's called the base number. You write that nice and big, and then how many times am I going to do that? Well, let's see, 1, 2, 3, 4, 5, 6. There's 6 of them, so this is called 5 to the 6th power. That's all you had to do on that one. Okay, you did not have to figure out the value of 5 to the 6th power. That'd be a big number. Here we do have to find the value, but it's just 7 to the 2nd power, which is the same as 7 times 7. Most popular wrong answer for that, you remember? 14. That's people when they think that you're going to multiply the base number times the exponent instead of the base number times itself that many times. 7 times 7. A lot of football fans like the 49ers. My second favorite team. Now you have to determine is number 3, is 111 a perfect square? Well, remember what perfect squares are. Those are numbers times themselves. 49 is a perfect square because it's 7 times itself. Only one time, right? So 7 to the 2nd power. Anything to the 2nd power you could say squared. So there's only 10 perfect squares between 1 and 100. That's 1, 4, 9, 16, 25, 36, 49, 8 times 8, 64, 9 times 9, 81, and 100. After 10 times 10, which is 100, you have 11 times 11, which is 121. 111 is in between those two, right? 10 squared is 100. And 11 squared is 121, so that cannot be a perfect square. So you say no on that one. This is a order of operation problem, number 4, and you're supposed to just make sure you follow the correct order. And I always say to solve these going down, one step at a time going down. First thing I'm going to do in that problem is parentheses, because in order of operations, parentheses takes cuts in front of everything. So 15 plus 1 is 16. Now I will continue to write what is left as I work my way down. Okay? Now, first I'm going to ask this question, what's going on with this 9 in parentheses? Do you remember? Yeah, you're supposed to multiply. So I'm going to go ahead and write a big dot in there. So I have subtracting, multiplying, dividing, and exponents. What comes next after parentheses? Exponents. And remember, that's not 8. That's 4 times 4, 16. So I'm going to go ahead and write this without parentheses since I have that times sign between the 9 and the 16. What do I do next? Subtract, multiply, or divide? Well, I'm going to multiply and divide from left to right. What does that mean from left to right? Well, if I had the division problem written first, I would do that before I multiply. But since the division problem is written second and multiplying first, I'm going to multiply first. So 9 times 16 is actually a gross number. Ew. Hopefully you get that. Gotta like those dad jokes, especially when they're math involved. Now I'm going to divide 144 by 16. Well, I just did 9 times 16, got 144, so 144 divided by 16 is going to be 9. And all I have left now is 10 minus 9, which is 1. Okay, all the factors of, or the factor pairs of 78, I like to write what's called a factor tower. Start with 1 times the number, and if it's even, I'm going to go 2. 7 plus 8 is 15. 3 goes into 15, so 3 is going to go into this. How many times? It ends up being 26. 4 won't fit because it's 2 times an odd number. 5 won't fit because it doesn't end in a 5 or 0. But 3 and 2 both fit, which means 6 will fit. And that's 6 times 13. And I believe that's all of them. 7 times 11, 77. 8 times 9 is 72. So we are done. Okay? So all the factor pairs are right here. And if it said to list all the factors, I would list 1, 2, 3, or 1 comma 2 comma 3 comma all the way up to 78, all the way around here. And the advantage of doing them like this in order is the only numbers left are 7, 8, 9, 10, 11, 12. So if I'm sure those aren't going into this, I'm done. You don't have to check all the numbers all the way up to 78. Okay. Prime factorization of 124. I'm going to start that with 2 times 62, and I'm going to circle the 2. This is called making a factor tree, and this is 2 times 31, and 31's prime. Once I've made my factor tree, I take those numbers I circled and make a multiplication problem. So 2 times 2 times 31. And you can rewrite that using exponents if you like. Instead of 2 times 2, you write 2 squared. Okay, either one of those answers would work. Okay. Greatest common factor, GCF. Remember, factors fit. Biggest number that fits into 20 and 80. Again, I think the easiest way to do these is using the up the stairs and out the door. 10 goes into 20 twice. 10 goes into 80 8 times. Well, 2 goes into both these, so let's make another stair. 2 goes into 2 once, and to 8 4 times. Nothing goes into 4 and 1 except for 1, so I'm done. The greatest common factor is up the stairs, so that means I'm going to go 10 times 2. Now, the shortcut on this one would have been, okay, you always want to sort of check and see if the small number fits in the big number. Since 20 fits into 80, 20 is going to be your greatest common factor. It's the biggest number that fits into 20. You can't get a bigger number to fit into 20. And 80, the bigger number, will be the least common multiple. You can't get a smaller multiple than 80 times 1. In this case, we wanted the greatest common factor. That's 20. Now we are getting least common multiple. Will 6 fit into 9? No. So can't do that shortcut I was talking about. But 3 fits into both these. 3 fits into 6 twice, into 9 3 times. Nothing goes into 2 and 3 except for 1, so I'm done. If I wanted the greatest common factor, that's up the stairs. It's just a 3. But I want the least common multiple. Remember, that's up the stairs and out the door. 3 times 2 times 3. 3 times 2 is 6. 6 times 3 is 18. That's the least common multiple, and that kind of makes sense if you listed the multiples and said 6, 12, 18, 24, 30, and then said 9, 18. Whoa, I can stop. Right? It's the smallest one that's a multiple of both. On to number 9. Each face of a cube is a square. Now, remember what a cube is. It's like a game die, right? 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 How many faces are on a cube? Well, how many numbers on a die? 6. So if I get the area of one of those faces, I have to multiply it by 6. And since each side length is 8 centimeters, each face is 8 times 8. Area of each face is 64, 8 times 8. Square centimeters. Now I have to multiply that 64 times 6 to get all of the faces, the total area of all the faces. So I'm going to go ahead and write that 6 times 64 over here. 6 times 4 is 24, carry the 2, and 36 plus 2 is 38. Okay, 384. Now you're not done with that number. Always include the units. And remember, for area, it's always square units. And you can write square centimeters like that. That's a little shortcut for you. Okay. Write a power that has a value greater than 340 and less than 345. This is a tough one, but I think I showed you the cheat last time. You could technically write 341 to the first power, 342 to the first power, 343 to the first power, 344 to the first power. Either of those are the cheats. Technically, you'd be right. What they were looking for is for you to figure out some powers. A lot of people got stuck on this because they were stuck with powers to the second power. And 16 times 16 is 256. 17 times 17 is 289. 18 to the second power is 324. And 19 to the second power is 361. Some people figured out those two and then said, this is impossible, Mr. Daniel. Right? Because 18 squared is 324, 19 squared is 361. How can I get one that's between 340 and 345? The trick there was you had to go to the third power. Okay, and 6 to the third power, 6 times 6 times 6 is 216. But 7 to the third power, 7 times 7 times 7, ends up being 7 times 49, which ends up being 343. So what they wanted you to find was 7 to the third power, but technically these are correct as well, so I accepted those. Okay, and that's the cheat I showed you on this, just like a problem we had on a quiz. Right? All right, flip it over. Halfway done. More than halfway done, but now we got these word problems. Okay, this word problem, fortunately, is just like a problem we did earlier in a quiz, right? Draw that picture. We have a garden, and it is 8 feet by 8 feet on the outside, and inside there's a smaller garden box that's 4 feet by 4 feet. And along the outside, we had 4 equal sections. Okay, so I don't know if you remember the easy way to do this, since we're getting areas, was to do it like this. These are all equal sections. If you did the the diagonal, then you had to get the area of a trapezoid. Most of you don't know that yet. So here we are. We got these 4 equal sections, and those 4 equal sections, they planted, let me see, veggies, right? Planted tomatoes, onions, zucchini, and peppers. So, and they're saying, what's the area of the onion? Well, it could be either of these, right? They're equal. So, 2 ways of doing this, probably more than 2 ways. Figure out how big this rectangle is. Well, if this whole thing is 8, and this is 4 in the middle, that means this top part and the bottom part are each going to be 2. So this is 2. And if the whole thing is 8, and each of these little sides of rectangles are 2, then this must be 6, right? Because 2 plus 6 is 8. So 6 times 2 is 12 square feet. That's one way of getting it. Another way of getting it is figure out the area of the entire thing, this 8 times 8, which is 64, and then get the area of the center spot with the flowers, 4 times 4 is 16, and subtract, and that would get the area of this big square donut, right? 64 minus 16 equals 48. Well, if 48 is the whole thing, and it got divided into 4 equal parts, what's 48 divided by 4? That's another way of getting that 12. Okay, so 12 square feet. But again, this was just like a problem we did on the quiz. So if you paid attention when we went over the quiz or cared about the problems you got wrong, this was an easy problem. If you didn't, hopefully you learned a lesson. Okay? All right. These are tough questions, these perfect squares. We will get used to perfect squares, but we want a greatest perfect square that's a factor of 147. Well, what goes into 147? 1 plus 4 is 5, plus 7 is 12. 3 goes into 12, so I know 3 goes into this. How many times? A lot of kids had to come over here, and don't be shy. Divide. You know 3 goes into it. You don't know how many times. Do a little long division. 3 won't go into 1, but it goes into 14 4 times. 4 times 3. What do I do now? Subtract. What do I do now? Bring down that next number. How many times does 3 go into 27? Perfect fit. And guess what? 49 is what? It's 7 squared. So 49 is the biggest perfect square that's a factor of 47. All right, you're filling piñatas for a friend. You have 12 kazoos, 18 mints, 24 lollipops. You want identical groups. What are they asking for here? This is a greatest common factor, and since 12 fits into 24 perfectly times 2, I'm just going to figure out, well, what's the 18 and 24 greatest common factor, and I know 6 goes into both those 3 times and 4 times. Ooh, nothing goes into 3 and 4. I'm done. 6 is the biggest, the greatest common factor, the biggest number that fits into all 3 of those. Okay. All right, almost there. 2 more. Stoplight A changes color every 45 seconds, and stoplight B changes color. Let's do the autofocus again. Every 80 seconds. Both of them changed color 60 seconds ago. After how many seconds will the stoplights change again at the same time? So it looks like we're looking for a least common multiple with a little twist. Okay, so I'm going to go ahead, let's figure out the least common multiple of 45 and 80. Those are the two things, the two different stoplights. I'm going to go up the stairs and out the door. What goes into both those? Well, that ends in 5, this ends in 0, so 5. 5 goes into 45 9 times. How many 5s fit into 80? It's 16, but if you didn't know that, come over here and do a little division. That long division comes in handy. 5 goes into 8 1 times. 5 times 1 is 5. Subtract. What do I do now? Bring down that next number. And 5 goes into 36 times. That's how you get that 16. So perfect fit. Does anything go into 9 and 16? Only 1. So I'm done. Now, least common multiple, I'm going up the stairs and out the door, right? We want a least common multiple of 45 and 80. Okay? So that's 5 times 9 times 16. Or 45 times 16. Or I could have done this first and got 80 times 9, which is easier, right? 5 times 16, I already know that's 80. So 80 times 9 is like 9 times 8, 72, with that extra 0, 720. So 720 is, every 720 seconds it's going to happen where both lights will change color at the same time. However, this question says it happened 60 seconds ago. When will it happen again? So I have to subtract. That was kind of a mean twist they added to this problem. Make it even harder. It was hard enough already, huh? So 12 minus 6. So in 660 seconds, and if you want to just figure out how many minutes that is, 60 is a minute. So this is going to be, what, 11 minutes. 11 minutes it's going to happen again. Either of those would work. I usually give you 1 point if you try a problem. These are all worth 3. If you got to the point where you got that 720, I probably gave you 2 points out of the 3. Okay, that was a pretty good work. All right, last one. Tank in the shape of a cube with edge lengths of 3 feet. Real quick, they're finding cubic. We haven't done volume yet. Why did they throw that in there? Which is why I said this was an extra credit question. If you are interested in volume, they got that tank. It's 3 by 3 by 3. To get the volume, you get the area of the base, which is 3 times 3, which is 9. And then say, how many layers of 9 do I have here? Well, you had 3 layers of 9. You know how we say 3 times 3 is the same as 3 to the second power, 3 squared? Well, 3 times 3 times 3 is called 3 cubed. So 3 cubed is 3 times 3 times 3, or 27. This was even harder than you thought, because that was how many cubic feet. And the dirty trick that they added to this, then they said, how many cubic yards? Yikes. Well, here's something for you. This is 1 yard wide, 1 yard deep, and 1 yard tall. So the answer for yards is 1 cubed. 1 cubic yard. Crazy, huh? This is a later chapter. We will deal with that later. So if you didn't get that, do not sweat. Okay, that's the end. Okay, hopefully this makes more sense to you now. If you did not do well on this, then you're watching this as an ed puzzle to earn your way to be able to do a retake. Okay, all right.